The RNP with radius to fix leg capability is mentioned in the advanced RNP concept. The radius to fix, RF, leg procedure is an additional capability to existing RNP operations. The radius to fix leg can be used in the following RNP procedures. RNP1. RNP approach in initial, intermediate and missed approach segments. The design criteria are identical to RNP1 design criteria. RNPAR. Radius to fix leg avoids FMS computed transitions, tangential arc of circle, and thus reduces the protection area on turn. Initially this function is coupled with RNP1 navigation specifications, SID, stars, and also RNP approach operations, in terminal area except in final approach segment, and in initial and intermediate segment of missed approach, with 1 nautical miles RNP value. The radius to fix leg is a flexibility for the procedure design of the RNP procedures in order to avoid terrain or obstacles. As illustrated on figure, compared to track to a fix transition, the protection areas are smaller in radius to fix leg. On track to a fix transition, the FMS computes a flyby transition with a constant bank angle. The bank angle depends on the ground speed or the flyby algorithm of the FMS. On radius to fix leg, the FMS adapts the bank angle to the defined trajectory. All aircraft perform the same repeatable trajectory. The airworthiness compliance of the aircraft with RNP1 or RNP approach with radius to fix leg requirements is declared in the AFM Part Limitations, 22 Autoflight System, Flight Management System, Airworthiness Standards Compliance. Advanced RNP operations are referred to as ARNP or ARNP. ARNP is composed of several functionalities introduced in the ICAO PBN manual in addition of NavSpec Nav 5, 2, 1, and RNP 2, 1 and RNP approach. The PBN manual, ICAO Doc 9613, in its 4th edition published in 2013, provides 6 RNP functions. Some are required, others are optional. The 6 functions are: radius to fix leg required, parallel offset required, RNP scalability optional, RNAV holding required, fixed radius transition optional, time of arrival control optional, not yet defined. The aim of the scalability function is to enable the design of procedure with reduced protection area. As defined by the ICAO, the scalability enables the use of a RNP value less than 1 nautical miles and as low as 0.3 nautical miles in the terminal area. However, ARNP operations are not part of RNPAR operations. Fixed radius transition, FRT, enables curved transitions between 2 legs with a defined constant radius, as illustrated on figure. This function is for the en route flight phase. The ARNP functions provide a design flexibility that supports the RNP procedures, in order to manage some operational constraints. Aircraft solutions. During PBN procedure, the aircraft navigation system enables the flight crew to set and monitor the appropriate navigation and approach mode. All along the flight, the aircraft systems perform the following tasks: compute position on the basis of the sensor's inputs. Estimate the accuracy and integrity of the aircraft position. Set limits defined in NDB or by phase of flight in accordance with PBN specifications. Monitor the accuracy and integrity with regard to these limits and trigger alerts to the flight crew. In this way, the existing aircraft functions that define and monitor the aircraft position answer to the PBN requirements. Aircraft positioning and monitoring. The navigation system collects position from different sources, as illustrated on figure. Inertial position from air data and inertial reference system. Global navigation satellite system position from multi-mode receiver. Radio position from nav aids, or and DME. With these different sources of aircraft position, the navigation system computes the following three different positions: GNSS, inertial position, also known as global positioning, and inertial reference system, that merges data from GNSS and inertial positions. NavAids, inertial position, that merges distance from DME and or ground stations and inertial positions. Inertial-only position, that merges different inertial positions. All these positioning modes are referred to as navigation modes.